Hey guys, welcome to question MM222 of the Maths Methods Fortify study guide. So we've got this figure, which is shown below, and it represents the shape of a company's logo. So the logo is made up of two right angle triangles, these ones here, and two semicircles as shown. A is a positive constant, and the angle CAD equals the angle CBD, which means these two angles here are the same, where theta is between 0 and pi on 2. Cool. Now, question A asks us to find AD and CD in terms of A and theta. So AD and CD we're looking for. Cool. So we know that AD is this length here and CD is this length here. So what we're actually going to do is just redraw this triangle and say that this is CD, this is AD, this is theta, and this is A. So A centimeters. Awesome. Now, to find AD, we know that, according to trig, that cos theta is equal to adjacent over hypotenuse, right? Where our adjacent is AD and our hypotenuse is A. That's equal to cos theta, which means that AD is equal to A cos theta. And that's fine, so that's our first mark. So we need to find AD and CD in terms of A and theta, which is exactly what we've done, A and theta, so that's our answer. Now for CD, we know that sine theta is equal to opposite over hypotenuse, which means that our opposite is CD, our hypotenuse is A, that's equal to sine theta. Therefore, CD is equal to A sine theta. That's our second mark. That's it for question A. So we've got our CD value here, got our AD value here, and yeah, it's pretty straightforward. We just need to make sure that we deal with this triangle in the way that the trig rules allow us to. So that's part A, and let's move on to part B. Now part B asks us to find the total length of the lines in the logo, which is given by T. So T. So this is the total length of the lines. And so let's just rewrite what we found in the previous question. So we knew that AD was equal to A cos theta and CD was equal to A sine theta. Awesome. Now, our total lines are just going to be all of these lines added together. So let's deal with that now. So we know that the total is going to be equal to, and let's just add all these together. So AD here plus DB plus BC plus CA plus CD, which is this line in here, plus both of these semicircles here, which are going to be maybe AC circle plus BC circle. Awesome. Now, AD is equal to A cos theta plus, now DB is exactly the same, right? So it's the same, same length, sorry, which means that we have A cos theta as well. And we know that because these thetas are the same and these lengths are the same as well. So this length must be the same there. Awesome. Then BC is just equal to A. So plus A, plus CA, which again is just equal to A, plus CD, which is equal to A sine theta, which is what we found before, plus AC semicircle. So we know that the perimeter of a circle is equal to 2 pi r, but because this is a semicircle, we're just going to do pi r, right? So pi times r, our radius of this circle is A on 2. So the diameter is A, which means that the radius is A on 2. Plus BC semicircle, and that's exactly the same as the other semicircle, so we can say that it's pi A on 2. Awesome. Now, kind of expanding all this out, grouping everything, we get 2A cos theta plus 2A plus A sine theta plus pi A. That's our first and only mark. So that's our final answer for part B. Part B. Keep forgetting to write that down. 1 mark. Yeah, so the biggest thing is just to add up all of these lines. Pretty standard. We just got to make sure that we get the right values. So that's part B. Let's move on to part C. Part C talks about dt d theta, right? So I shouldn't have rubbed that out. So part C tells us to find dt d theta and hence show that the length t is at a maximum when AD equals 2CD. So max at 2CD equals AD. Awesome. We need to basically show this. So from the previous question, we know that t is equal to, sorry guys, I shouldn't have rubbed that out below. So 2a cos theta plus 2a plus a sine theta plus pi a. We need to find dt d theta, which is the derivative of this. So because these are separate terms, we can just kind of treat them as their own things. Now 2a cos theta, because a is a constant, it's just like a regular cos differentiation. So the derivative of cos theta is negative sine theta, which means that the derivative of this section here is going to be negative 2a sine theta. And the a doesn't change because it's just a constant, like I said. 2a is just a constant, so that's actually just going to turn into 0. That's going to cancel out. The derivative of a sine theta is a cos theta. And again, pi a is simply a constant, so that's going to change into 0. Which means that our derivative is this. So that's our first mark out of 2. We found the derivative, and now we need to show that the length t is at a maximum when AD equals 2CD. Cool. So if our length is at a maximum, it means that the gradient is equal to 0, right? So dt d theta equals 0. So at max, dt d theta equals 0. Therefore 0 is equal to negative 2a sine theta plus a cos theta. Rearranging this, we bring this over here, which means we get 2a sine theta equals a cos theta. Now, we know that a sine theta is equal to CD. We found that out before. And a cos theta is equal to AD, which means that 2CD equals AD. As required, that's what we were tasked to find. So show that the maximum occurs at 2CD equals AD. That's what we've done. So that's our second mark. That's it for part C. Let's move on to part D. Part D is a really, really difficult question. And I think that there's been a similar question to this on the Pass VCAR exam, on a Pass VCAR exam, and I think it was like 3% of people got this right. So if you struggle with this, don't stress. It is quite difficult. So this is part D. This is worth 3 marks. So let's run through it. So the question tells us, or asks us, find the maximum value of t if a equals 2 root 5. So a is equal to 2 root 5. Now, we know that the maximum value of t occurs when 2a sine theta equals a cos theta. That's what we found in the previous question, right? Which means that if we divide both sides by cos theta, you can get 2a sine theta over cos theta equals a, right? I've just divided both sides by cos theta. And then dividing both sides by 2a, we get sine theta over cos theta is equal to a over 2a. Sine theta over cos theta is tan theta. A over 2a is simply 1 on 2. So this is our first mark here, and you'll see why we had to do this in a second. But actually, you know what? Let's just go into the next part. So if tan theta is equal to 1 on 2, that means that if we have our triangle, just any triangle, this isn't necessarily this triangle, it's just the triangle that represents tan theta equals 1 on 2. We know that tan theta is equal to opposite over adjacent, which means that if this is theta, our opposite is 1 and our adjacent is 2, right? 1 on 2, adjacent over opposite over adjacent. Which means that this length here, according to Pythagoras, is equal to, so if this was c, let's say, c squared is equal to 1 squared plus 2 squared, which means that c is equal to the square root of 1 plus 4, which is equal to root 5, right? So this is root 5 here. Now, according to this triangle, cos theta is equal to adjacent over hypotenuse, which means 2 over root 5. Sine theta is equal to opposite over hypotenuse, which is 1 over root 5. So our whole idea of doing this is so that we can plug values into our our formula for t. So this is our second mark. We get cos theta and sine theta as actual values. And what we're now going to do is actually just sub these values into our t formula, right? So I can get rid of this. I'm also just going to get rid of this as well. Awesome. We also know that a is equal to 2 root 5. Sweet. So our equation for t is 2a cos theta plus 2a plus a sine theta plus pi a. We know what a is, 2 root 5. We know what cos theta is, and we know what sine theta is. So we can actually get a value for t. So 2 times 2 root 5 times cos theta, which is 2 on root 5, plus 2 times a, which is 2 root 5, plus a, which is 2 root 5, sine theta, which is 1 on root 5, plus pi times a, which is 2 root 5. Awesome. From here, we can simplify all that down. I would actually just do this on my CAS, because by this point you've already got 2 marks, so you really just need to get to the answer now. So this all simplifies to 8 plus 4 root 5 plus 2 pi root 5, which can then simplify to 10 plus 2 root 5, 2 plus pi centimeters. And the centimeters is important, guys, because we're talking about length, so we need to have a unit there. This is an insane question, so again, don't stress if you weren't sure about it or you couldn't get it. Really, really difficult. This is really to distinguish between, you know, the top 5% and the top 2 or 3%. If you didn't write it in this format, that's fine. Like any format that, you know, you can kind of put it in is fine, as long as you get the equivalent answer. So that's it for MM222. Hit me up in the comments below if you have any questions. I know this was tough, but yeah, just try your best and see how you go. But thanks for watching, and I'll see you in the next video.